What's up, guys? Welcome back to Vanover Machine and Repair, and in today's video we have a nice controversial one for you. We're working on our Hyster 60EZ. We have a small mini series and we've been concerning ourselves with the battery on this unit. Now when we got it, we could barely operate the unit. The battery was in such bad shape, and we've brought it to a point where we can drive it around and use it for about 30 minutes, but frankly we just need a little bit more out of the battery. So in today's video, we're gonna bring you through the process of pulling the battery out and trying to recondition it as best as we can. So with that said, let me bring you in close and show you the details. Now, I'm definitely not an expert on reconditioning batteries, but for the last 3 weeks, I've been knee deep in as much research and talking to people who do this professionally to sort of figure out what are some of the best methods for doing this. Now, my opinion is that the best possible method is what they do in third world countries. They actually take the batteries out, they open the cells, they clean the plates, they clean the plastic case, they reassemble everything, and they actually add new acid, charge up the battery, and for the most part, the battery is good as new. A battery doesn't actually have any wear parts on the inside, but what happens is over time, sulfates build up on the plates, they contaminate that insulation paper, and that basically reduces the capacity. So by fully disassembling it, you can save the lead, make sure everything's clean, and you should, in theory, have a brand new battery. Now, for the most part, we don't do that here in America because the labor to do that is pretty intense, and also it's a little bit of a dangerous process because you're working with the acid. You have to use a lot of ventilation, and frankly, with the regulations here, that's why we don't really do that. The second method is probably the second best option, and that's what most battery rebuilders do here in the States. And what that is they take the batteries out, they bring them back to their facility, they undo all of the connection, the inner cell connectors, and they test each cell individually. If they locate a bad cell or 2 or 3, they pull those cells out, they scrap them or recycle them, they install new cells, they go ahead and resolder all the interlink connectors, and they desulfate the battery and slowly discharge and recharge it with a proprietary charger. Then they resell that as an 70-80% good battery, and it should last 3 to 4 years. And that works quite well. You would be surprised how much bad cells really pull down the capacity of the battery because they're actually connected to the cells around them. And then obviously the last method is probably the least effective, and that is doing kind of the quick tricks and gimmicks and doing some of the things that we've did prior just to see if you get lucky. Stuff like adding acid to the batteries, adding distilled water, making sure all the pH levels are balanced, using a small cheap desulfator, adjusting the battery levels, and even using a desulfation charge on a charger. It does work, and in our case we did get some capacity back, but the rebuilding of doing it that way is pretty limited because you're not doing anything inside the battery and you're not addressing any of the dead cells. Now in our case, our battery came to us pretty much non-operational. And this is really important to keep in mind if you're going to attempt to rebuild your battery, and that is you can't have any success if you have dead cells or if your battery is just not up to the right charge level. So if you're starting with a battery that's been sitting for a while, you want to do your best to fully charge the battery, and to do that over time. Maybe charge it on one day, let it rest, discharge it, recharge it, and then equalize all of the cells. Now obviously if you have a bad cell, which most likely you do if you're watching this video, we need to address that. But you don't want to go in here and start working on the battery if your battery is bone dead and if it's been sitting for quite some time without any use case. So that's what we did in our case. The battery came to us mostly sitting. We actually had an entire row here in the back that was disconnected. They tried to bypass this row because there were a couple bad cells. They rewired the battery for the front 3 rows and reprogrammed the forklift to 36 volts. Now that can work, but in our case it didn't really work out too well because there was a couple of dead cells in the front and the battery was neglected and it sat anyway. So when we got it, we went through a process of reconnecting the battery back to 48 volts, But before we did that, we charged up this back row very slowly over several days and brought the voltage back up on this back row. Now, a lot of the dead cells that we have are testing much better than they tested in the beginning. However, we want to be able to get a little bit more capacity out of our battery, so that's why we're going down this method of pulling the battery out and trying to do a more thorough rebuild. Before we go ahead and remove this battery, I want to just talk about some basic testing methods, so that way you know where you stand before you even start. Now, in terms of battery sizes, the most common sizes are 24 volt, which is more common on a walk behind, 36 volt, 48 volt, and even 80 volt, with 36 volt being the most common. Now, a battery is made up of cells. Each one of these squares is a cell, and in general, the cells are 2 volts. So when you come up to your battery, what you're looking to do is you're looking to test the resistance and also the voltage of the battery. So you'll be testing between each lead, positive and negative, and you'll be looking for somewhere around 2 to 2.3 volts ideally. If you have anything below 2 volts, that's going to indicate that you have a problem. So in our case, when we measured this battery when we got it, we went around with the meter, we tested everything, and a majority of the cells read somewhere around 2 to 2.1, 2.2 volts, but a couple of these cells marked with the pink nail polish were testing 1.9, 1.6. What that tells us is the voltage on those cells is low, and so they were not accepting a charge to the same level as the other cells around them. Now, all that tells us is the battery voltage. That does not tell us the internal resistance, and that's a little bit harder to calculate. However, what you can do is you can put the battery on a charger and repeat the same measurement and see which cells have a voltage drop, meaning that their voltage goes down under a load. And we were able to repeat the same test, putting our meter between the positive and negative on each cell, and the same cells that were struggling before read a lower voltage during charging, whereas the better cells maintained a higher voltage under charging. So that's how we were able to isolate our bad cells. So if we're going to go about replacing individual cells, that would be the first step, is identifying which cells are bad. And as an aside, if you do have only one bad cell, maybe two, some people do actually skip that cell. It's not really recommended because the source voltage on your battery is going to come from 48 to 46 as an example. However, it can work and get you out of a pinch, but I wouldn't recommend doing it, especially if you have more than 1 or 2 bad cells, because the input voltage is going to be severely reduced. And obviously, if you have a 24 volt battery and you take one cell out, that's a much bigger percentage of the battery's voltage than if you have a 48 or 80 volt battery. So just keep that in mind. One last thing that I'll mention before we remove this battery and start the process is, for us, the main reason we're doing this is amp draw and capacity. So the difference between amp draw and voltage is this. Our battery, when we started, would not accept a charge, and the voltage of the battery was wrong, and the voltage of these last cells was too low. After a variety of charge cycles and reconnecting all the batteries, the voltage was where it needed to be, and the charger was happy. However, the actual amp draw or amp hour capacity was significantly reduced. So as an example, if I drove this forklift around and lifted small light objects, it would be fine. But if I drove this forklift at full throttle, or I tried to lift something heavy, the amp draw would be too high because the battery's internal resistance is too high, and the forklift would error out. So on paper, this battery looks like it holds a good charge, and this battery also shows good voltage, even on some of these cells that showed up dead before. However, the main issue that we're fighting is that amp capacity, and because we do a lot of heavy lifting in the shop, I do need this forklift to work at a higher weight capacity. So the plan is to come in here and to clean these cells up and get them to the point where they can actually not only hold the correct voltage, but also be able to output enough current to sufficiently use the forklift as it was intended. With the forklift battery out of the unit, we can go ahead and start the next step, which is going to be removing all these inner cell connectors. Now, these inner cell connectors are common. You can get them on the internet. We went ahead and ordered a new one of these 4 links for this, so we could address that. And then we ordered a couple extras as well, just to have on hand. If we do this properly, we should be able to reuse most of these, but we also picked up some lead just so we have some extra materials if we need it. Now, our battery is still bubbling because it came off the equalized charge not too long ago, so we're gonna let this sit overnight, allow some of the hydrogen to relax, and then we'll come back in and we'll start removing these connectors. I'm just going to clean up the top of the batteries here so we can mark them. With the cells cleaned off, I'm going to go ahead and mark each cell. That way I know the original orientation, and that way for my note taking, we can identify which number cell is bad and what the ratings are. All right, so before we go ahead and take off these terminals, we're going and testing the battery. So what we're doing is we're hooking up a load tester, and we're trying to see the voltage drop from cell to cell. This is gonna let us know which cells are truly bad under load. Currently, we're giving it about 250 amps, and we have a list, and we've identified a couple cells that really drop down low. So we're just going through each cells, all 24 of them, to see which ones are really bad. So on this cell here, what we're gonna do is we're gonna apply a load of 250 amps, and it's gonna drop down to
This is 1.07.
1.07.
So it's also bad. We marked it as bad before. I can show you this one.
Just
this
as
is
a
the worst
comparison.
one. This is the worst one right now. No load. As soon as we apply 200 amps,
Goes all the way down to 0.3.
0.3.
So it's losing most of its voltage under load. So that's a bad one.
This is probably the worst of the whole lot.
Okay.
Okay, let's move to the next
All
one.
right, that was 23.
Yes. So 1 volt, 0.3, 1.7. Our diagnosis the first time was not bad.
Yeah.
The ones that we marked were actually the worst ones.
This is a little more accurate since we were working with a pulsing signal.
It's more accurate because you're putting a real load. That's the only difference. But I mean, the way we're measuring it, you will see it's the same, right? Internal resistance is just the only variable we have in here. 1.84.
21.
21. 1.72.
20.
Yeah.
So far we have number 1 is 1.1.
And 11.
11 and 12, yep.
We missed 11 last time. Okay.
And we got 18 at 0.9, 23, and 22. All right, so we went ahead and did a voltage drop test on each cell, and what we figured out is we have 5 bad cells that are not even close to holding voltage under load. So what we're gonna do before we take the interlink connectors off is we have a stick welder. Now I know we struggled with our other stick welder, which was inverter based and not set up properly, but we're gonna be doing the process correctly this time, and we're gonna come in and try to zap the terminals or the cells that are in rough shape and see if we can desulfate them, and then we'll reload test them to see if we have an improvement. All right, so we're over here by the door for ventilation. We have the stick welder hooked up to the bad cell, or one of the worst cells, which is number 22. We're using what? All 200 amps with the stick welder. We're giving it everything she's got, and we're watching, we're monitoring the temps, and we see some bubbling and some of the sulfates coming off. So we're just gonna monitor this and monitor the temperature. And once it starts getting warm, we'll take a break.
Well, that's good. It's bubbling, it's doing the thing.
We have the battery back over here on the ground inside the shop, and we had it over at the door testing with the welder, trying to see if we could revive some of these cells, and we didn't have a lot of luck. Now, there was a Project Farm video where he did that on some batteries and had some success, but I think because these batteries have more capacity, they just require a lot more amps to desulfate the battery, and we were giving it about 200 amps from the welder for about 30 minutes, and we weren't making any progress. So after some more consideration, we've decided that we've done everything up to this point to try to save this battery and these cells with the kind of quicker, easier methods, and now we're gonna move on to addressing this properly. We found a place that we can purchase reconditioned battery cells for about $250 a cell. And so instead of spending $6K on a reconditioned battery, we're gonna go in here and replace 6 bad cells with new reconditioned units, and that should get us where we need to go. So in order to do that, we need to come in here and remove these interlink connectors where they are coming across batteries we need to replace, and we'll get the batteries removed while we wait for the new cells to come in. The process for removing these is actually pretty easy. They do make a special tool for drilling down, which saves the center of the post and relieves the perimeter. A hole saw is something that you can use in lieu of that special tool, and I took it one step further and I modified a hole saw. Basically, I just cut in some extra gullets so that way the lead doesn't pack up as much, and then I sharpened some of the teeth. And we'll come in here and we'll get started with this. That'll give us a nice starting point, and then once we have a nice circle, we'll switch to this guy, and it should allow us to come in and basically core out the center and save the actual battery post. There it is. My modified hole saw didn't work out too well, so what we did is we just switched to the factory hole saw. I did notch the teeth a little bit. I think my gullets were a little big and some of the teeth were popping out. And then we're using some anchor lube. The anchor lube is kind of helping with it gumming. So I'm going to come in with the pilot bit, and I'm going to go over to all the ones we need to remove and pilot all of them with the same bit in an assembly line fashion, and then we'll take the pilot bit out and we'll finish using the anchor lube, and that should work pretty smoothly. So we'll start over here. All right, now that we got all these started, let's see if we can have a little more success. Wow, that's perfect. Looks excellent. We have all the inner cell connectors removed, and I just cleaned up the battery. So next we're gonna go and rip out this silicone, and then after that we'll go ahead and pull the cells that we need to replace. Just using an automotive seal puller here. We got all the sealer removed and we're ready to remove our first cell. Now we're going to try this method, basically clamping on the terminal post, and I have a crane. So we'll see if that works. I don't have a lot of hope, but these cells are bad and they're getting changed. So if we damage them, I'm not too worried. That's not going to work. We'll go to the next method. All right, take two. Bent up an eye hook. All right, let's try that again. All right, that was a failure. Let's try something else. Yeah, that didn't work at all. All right, that was a complete failure. Let's try this one next to it. Maybe we can get some luck helping that one out. Looks like the batteries are stuck. All right, it looks like the double hook is getting it done. Here she comes. Man, that was a chore. We got all the cells out, and the one in the back wasn't too bad, but the cells over here on this side were a major pain in the butt. You saw us damage the battery tops trying to get them out, and overall it took me quite a long time, but we did get them all removed. With the cells over here removed, we had between 1/8 and 1/4 inch of rust from the acid leakage, and that was what was holding these cells in. It was just really tight. So off camera, I went ahead and power washed this area and needle scaled all these sides so that the new cells will slide in nice and easy. I'm gonna go ahead and just paint this black to kind of prevent any future corrosion, and then we'll be ready to slide the new cells in. As for the cells we're going to be putting back, let's talk about these, because this was a little bit of an interesting journey. So finding just the cells online is a little bit challenging. And I did find a gentleman who is a battery rebuilder who agreed to sell me these cells at my own risk. And here's what we mean by that. So originally, I was going to buy these cells online. You can actually purchase replacement cells, and you can buy them new. They're about $400 to $600 per cell. Now, I didn't know this at the time, but right before I was going to pull the trigger on that, this guy reached back out to me, and he had some reconditioned cells or used cells. And when I decided to go with these used cells, because they were cheaper, I went over and talked to the gentleman, and he severely advised against using new cells in this battery or in any reconditioned battery. And the reason for that is new cells have a higher surface voltage and are in generally better condition. And in the same way that a bad cell affects the battery around it, so does a good cell. That being said, I was able to acquire these cells for $200 a cell used, and they're also the same brand as our battery, which is Hawker, which is another thing that I didn't know. Apparently the Hawker batteries are a little bit differently sized than other batteries. Now there is a standard size, which I believe these fit into, but a couple of the replacement cells are sometimes half an inch taller or shorter, which can be a problem when you go to weld on the terminals because your batteries are at different heights. So ideally, you want to replace cells on your battery with cells that are of the same brand and of a similar age and charge cycle. So in our case, these cells are from 2021. They are from a Hawker battery. The size is exactly the same. However, they are a little bit newer compared to our almost 20-year-old cells. So hopefully this works out well for us, and we'll talk a little bit more about that in a minute. But the moral of the story is if you're going to be replacing these cells on your battery one at a time, try to find cells that are the same manufacturer, the same size, and a similar age. So with that being said, let's get these guys unwrapped. Then we'll talk a little bit more about the batteries or cells that we got. And I want to review some of the stuff I learned at the battery supplier, which may be of value to you guys. I want to address the elephant in the room, and that is, by this point in this battery reconditioning exploration process, we probably would have been better just writing a check, getting a reconditioned battery, and calling it a day. However, the reason why this probably is going to still be good is we're probably going to save a couple $1,000s, be able to limp this battery along for a little bit longer, but more importantly, we have learned a ton about reconditioning batteries, replacing cells, maintaining batteries, and we're able to bring a video to you guys along the way where hopefully you guys can learn some. So for all of that, I think this is still worth it, but this has become a lot more work, been a lot more involved than we sort of anticipated, which is pretty much always how it goes. There's a reason why each industry is siloed off. It's because generally a lot of things take a lot of work, and there's a reason to specialize in that. I want to take a chance and talk about my experience at Chicago Industrial Battery, where we got these battery cells, and Mark was extremely helpful to me. I spent a lot of time researching, as I always do, on videos, on forums about battery replacement, reconditioning, cells, and Mark was able to give me some information that I really couldn't find online, and I wanted to share that with you because I thought it could be valuable if any of you guys are going down this road of looking at your battery, assessing whether it's worth it, that kind of thing. So the first thing is, I asked him straight up, do these things work? So I paid for this. It's a Power Pulse PP-48-L. Didn't even open it. In the beginning, when I was trying different cheap, quick fixes, this came up, and he said that these are a scam. It's a desulfator that basically attaches to the battery, desulfates it all the time, and he said the reality is with these guys, they just don't have enough current and voltage, and honestly, the desulfators on the higher quality chargers do a way better job than these, and so he would recommend against installing these on the battery. So I thought that was pretty cool. He's been doing this for about 30 years. He has no stake in the game, but obviously the people selling all these devices want to make you believe miracles, and I kind of was doubtful, but he confirmed my suspicions. The second thing is, when it comes to cell replacement, replacing any more than 2 cells, he would say is fairly risky. And the reason for that is a new cell comes in at about 2.7 volts, and when you bring in a battery for reconditioning, the cell voltage on all the other cells is going to be like 2.3, 2.4. So that voltage differential on those other cells affects negatively the batteries around it. Now, arguably, it's significantly better than a dead cell, but it's still going to affect the performance of the other cells. So when you replace 1 or 2, it has less of an effect than if you replace 5 or 6. So in our case, what we're doing by replacing 6 cells, he would highly discourage, and in his shop, he would just scrap the battery because the risk is too high. The other thing that I didn't know is I looked online and found multiple suppliers who would sell me either new or reconditioned cells, but they didn't give any information about brand or any information about the size aside from the standard 85-21 size. And he informed me that in that 85-21 size, there's actually 2 or 3 different heights. And if the battery is a different height, it's going to be a problem when soldering the inner link connectors. So he was able to supply me with the exact same brand, which in our case is Hawker. The batteries will be the exact same size, and they won't have any issue during soldering. The other thing that he likes to do is he likes to match the cells that he replaces with the new reconditioned cells that he gets of a similar age and cycle rating. So he said whenever possible, he avoids replacing cells with brand new cells. He likes to replace dead cells with used cells that test good. That way the balance that we were talking about earlier between that 2.7 and 2.4 is going to be closer to like a 2.4 and a 2.5 or a 2.4 and a 2.3. And that's just going to promote that battery blending in with the other cells around it. So that's something that I also found pretty interesting. I also had a chance to talk to him about distilled water versus regular water, and he basically said that regular water is fine as long as it's not well water. The well water is not filtered to the right amount, but basically in the past, before filtration was good, distilled water was mandatory because it was filtered at a higher ratio, but a lot of municipal townships these days have a lot higher standards than they used to, and so the tap water is actually a lot better, and tap water is completely sufficient for keeping the batteries fully hydrated. And the last thing I want to address is equalizing and desulfating. Now we kind of talked about that with these guys, but desulfation/equalization is really important, and it's important for us because we're not going to be using our forklift that often. Maybe we'll use it an hour on one day, maybe we won't use it at all the next 2 days, maybe it's 2 hours one day, maybe it goes a week. So for us, we need to desulfate or equalize every charge or every other charge, and we need to make sure that the water is fully covering the plates. That's going to give us the longest service life. Now, if you guys are using your truck every day for 6 hours a day, you only need to equalize it once a month, but that equalization cycle is crucial to make sure that all the batteries are at a similar voltage and that there's no major differential in voltage, which is going to affect the battery performance. So my charger has an equalization mode and it works sufficient. And I asked him if our charger, the impact charger, is better or worse than the industrial units he has to revive batteries, and he said the technology is pretty much the same. So that should be able to do a good job equalizing our battery and desulfating it as long as we do it regularly. Now he did mention that some of the older transformer chargers that you can still get, some of those do not have an equalization cycle, and that's problematic even on any battery because you want to balance them or equalize them occasionally so that way that they can last as long as possible. So with that being said, we're going to jump right into getting the cells in and soldering everything on, but I wanted to just take some time because the stuff that I learned with Mark I think was valuable for me, and I hope that that info is helpful for some of you guys. These cells came to us out of a 48-volt battery that he converted to 36. So the last row is still soldered together. So if we are smart, we can leave a couple of these together and minimize some soldering. So we're going to pop off these caps. In our battery arrangement, we have 2 sections that require a double battery. So if we can split these 5 into 1 and then 2 pairs, that'll help us save some soldering. So we'll get these caps popped off, and then we'll break this in half, and then we'll break off one cell. I went ahead and applied some fluid film here just to help these batteries slide in a little easier. Let's get these second pair in here. Make sure my orientation is correct, and it is. Goes in a lot easier without all that rust. Now that we got all the cells in place, we're going to prepare for soldering / welding all the inner cell connectors on. And the most important thing that we need to be aware of is making sure we have a good connection. So we're going to come in here with a wire brush and one of these battery terminal cleaners and get down here and clean up all these posts that have been exposed until all the lead is nice and shiny. All right, for the inner cell connectors, you can reuse the old ones, but a lot of times it's just easier to get the new ones. The new ones are easier to work with, and they're pretty cheap. Now, these style are a little bit oversized. If you look at the old ones, they make a more low-profile unit, but these oversized ones make it easier to solder because they have a thicker wall. They're less likely to blow out. I got these thicker ones from Mark. And you want to make sure that you properly wire brush the inside so it's nice and clean. And I'm going to hit this with a drill off camera just a little bit more. But we want a nice, clean, brushed look. And then we'll go ahead and drop these on in all the right locations. We are ready to start welding. We got our inner cell connectors on, and these are really nice. They gave us a little bit extra meat because on some of these cells we needed to grind in either direction to make sure that these guys would fit. We want to make sure that there's a decent amount of room around each post for that lead to go ahead and melt in. We're going to go ahead and melt the stick using this oxy torch, and then once it's melted down, we'll kind of come around the perimeter and make sure the lead is sort of wetted in nice. We have our PPE, and we went ahead and blew off any excess hydrogen. There shouldn't be any. This battery has been sitting for probably a week at this point since it's been charged, but just in case there was any, be nice and safe. So let's come in here and get these guys welded out. Now this is the first time doing this, so we'll see how it goes. That's probably good that we caught that on camera even after blowing all the air out. I'm going to take a wet rag and cover the vent. We got all the welding done and it turned out pretty good. Obviously we started here, we finished over there, we got quite a bit better as we went. We did get good penetration. I realized in the beginning I wasn't getting enough heat. So it was just a combination of getting enough heat to where it would wet out, but not too much, and it would kind of puddle out, and got better as I went. So now I'm gonna go around and kind of clean a lot of this stuff up, make it look a little bit nicer, and then I'm gonna do some, top everything off with distilled water, because the levels were a little low. Then we'll do some load testing, and then we'll go from there. All right, we got our solder job cleaned up. We added water to all the batteries. We're just gonna come through and do some load testing, and then this battery is gonna go on the charger. It's gonna be doing an equalized cycle. And once my acid comes in, basically what we're gonna do is we're gonna add some acid to the batteries that are not marked in red, which are the old batteries. And we're gonna measure the specific gravity and make adjustments while on the equalized cycle. So let me go ahead and bring over the carbon pile tester and just do some basic amp checking. We have our amp tester hooked up and we are testing the 3 newest cells. Originally the cells over here were load testing to 50 to 100 amps. So let's take a look at our carbon pile tester. 700 amps. Not bad, major improvement. After that test, I'm feeling pretty confident. I went ahead and tested a couple other cells, and they're testing between 600 and 800 amps. That is a major improvement compared to where we were before. The next step is to go ahead and put the caps back on this battery. We'll get it back in the forklift, and we're gonna get an equalized charge and adjust the specific gravity levels, and we'll kind of go from there. All right, let's do a load test with the forklift, see practically how it's doing. We're gonna lift this saddle. This saddle is about 6,000 pounds. The last couple times I lifted this, I could do it 3 or 4 times, and then it would air out. So let's see. 1. 6. Go for 10. 6 was the limit last time. Again, this is about 6,500 pounds. 11. Remember, we haven't balanced anything yet. This is just straight how it came. 14. All right, I'm happy with that for the load test. We got our acid in and we are ready to start balancing the acid levels in the battery. But before we go ahead and do that, I want to talk about the process. Like before, I did a bunch of research and I talked to Mark over at Chicago Industrial Battery, and there is not a lot of content on how to do this. So I wanted to walk through the steps. There's a few different methods, but the general way to do it is pretty consistent among the different methods. So the first thing is, why are we doing this? If you do a quick Google search, the AI results will come back and say that you should never add battery acid, you should only add water, basically discouraging you from doing this. However, if you take your battery into a rebuilder, they always do this when they recondition a battery. So let me kind of dispel some of that. The reason why, in general, they say not to do this is because adding acid is dangerous, right? The acid itself, gets all over you and can cause harm to your skin. There's fumes. Working with it is dangerous. The second reason is when you look at the life of the electrolyte level or the specific gravity of a battery over time, when a battery is brand new, it starts off at, let's say, 1280. It actually starts to increase for the first couple years, and then it slowly decays over time or decreases. And that's just how it is. It's expected. So the reason they tell you never to add acid is because batteries just have a higher percentage, and then over time they kind of go down, and it just is what it is. You add water to keep the levels up to make sure that the plates are covered, but the acid is just always going to kind of degrade over time, and it just is what it is. Now, the reason why they address the acid levels at battery reconditioner is because we're trying to get the battery in the healthiest state possible. And I think it's important to understand that when you're doing this, you have to weigh the condition of the battery. In our case, the battery is nearly 20 years old, and we're just trying to help it along, but we can't have an unrealistic expectation that by bringing the acid level back or the specific gravity, it's just going to become new again. That's not realistic. The level has been slowly declining, and it's very low. And so, you just have to keep in mind what you're doing. But with that being said, we are going to be adding acid, and we are going to be trying to achieve the proper acid level adjustment in terms of the ratio or the specific gravity, because we want our battery to last as long as possible. And our goal is to be able to kick this battery down the road for as long as we can. But we will have to replace it at some point. So in order to do that, there is a proper procedure to be able to accurately read the levels, because if we just go over there and suck up some of the fluid and read the specific gravity, that's not going to be accurate. So the first and foremost, before we go ahead and add any fluid, we want to make sure that the battery is in the best possible condition. And what that means is you want to make sure the battery has been fully charged and discharged several times, and all the fluid or water is up to over the plates. That's going to make sure that the battery is healthy, or as healthy as it can be, and ready to go. You don't want to be adding acid and measuring the specific gravity if the water is below the plates, or if the battery's dead, or if it's been sitting for a while. You want to make sure the battery is been in use, charged and equalized, and in its best condition to test the specific gravity. The other thing is the temperature. A lot of these specific gravity numbers are at 77 degrees Fahrenheit. So if it's super cold, that's going to affect the reading. If it's super hot, that's going to affect the reading. And some of the specific gravity measurements have adjustments based on temperature, so just be aware of that. So once the battery is in the best possible health, what we're going to do is we're going to get a little spreadsheet out with all the cells. We're going to go over there and we're going to put it on a charge cycle just to get the battery sort of bubbling and some mixing happening. And we're going to measure all of the cells, and we're going to record the specific gravity. Now, in general, usually about a 1/4 inch of solid acid will increase the battery's specific gravity about 50 points. Now, this acid we have in front of us is what is consumer grade available, which means it's diluted. So it's 37%. The stuff that they use at the battery reconditioners is 100%. They cut that themselves, and it's pretty hard to get. So we're going to need even more acid to achieve that. Now, the advice that I was given by Mark was to go ahead and suck the water down to the top of the plate or the mesh, and then basically fill it all the way up to the cap, equalize it, and then recheck it an hour later, because we want to make sure that that acid basically cycles. And if it's on the charger kind of creates the bubbling and creates the mixing of the fluid. So that's a fair amount of acid, and we probably don't even have enough acid here to do that. I ordered the wrong amount, and I need to order a bigger container, but this will kind of get us started. The other thing I want to keep in mind is when we're adding the acid, we don't want to just pour it in and check it. Same thing with the water. If you're adding water and you want to measure the gravity, don't pour it in and check it, because when you do that, you're just measuring the chemical you just poured directly on top. Now, this acid will settle to the bottom. However, we want everything to mix properly. So the best way to do this is kind of slowly over time. Meaning that we go over there, we make our recordings, we add some acid, we let it charge, we use the forklift, we let it charge, we take our readings, and we slowly add acid That's going to be the safest method, and that's going to allow us to sort of add acid without over watering the battery with acid. So that's kind of the 10,000 foot view that I wanted to give you guys some context on. We're going to go over to the battery and start by taking measurements. It just came off the equalized charge, and then we'll start to add acid over time. Obviously, PPE is important. We don't want to get this on our skin, so wearing gloves and using a funnel is ideal. So let's head over to the battery and start adjusting the acid and taking some measurements. We're over at the battery, and I made a little chart here with the cell numbers, the specific gravity before charge, after charge, some notes so we can indicate which cells are the new ones, and then we do a follow-up in a couple days and see where we're at. So I'm just going to come through, and we're going to start at cell number 1, which is always the cell over here at the positive terminal, and we're just going to suck up some fluid. And I don't know if you can see that, but this cell is good. It's in the green. It's reading 1275. So that's good. So we will record that. And then we will go on to cell number 2. Do the same thing. And you want to make sure when you're doing this that the bulb is floating, otherwise you'll get a false reading. We are at 1250. All right, so we'll record that. And I'm not going to show you this whole process, but we're going to go and measure all of these. It's very simple. You just suck it up, make sure the bulb is floating, and record the measurement. All right, we went ahead and measured all the cells, and this is where we came up with. Overall, we're looking a lot better than we were when we started the process, but by the book, we're not looking great. So we want to be around 1280 plus or minus 10, and it is temperature dependent, but we're shooting around 1280 is what we're going for. And we have one as low as 1215, which is pretty low, and we have one as high as 1350, which is pretty high. So what we're going to do is we're going to focus on the outliers. So the ones that are 1250 and below, we're going to add some acid to. And the ones that are 300 and above, or 1300, we're going to add some water to try to dilute the acid. Now, this is a really simple step. How much acid? I don't know. We're going to add a little bit of acid. We're going to drive it around for a week. We're going to charge it. We're going to recheck it. I'm not going to show you that. But if you're doing this by yourself, it's better to add a little bit of acid, check it, adjust, check it, adjust, then pour a bunch of acid in. Honestly, we're a little bit closer than I thought we were. Yesterday when I left, we were in the red on all of these, which was sub 1100, and we're looking a lot better now that it equalized. So I do think we are going to need to add some acid, but not nearly as much as I thought, which is good. So I'm going to come in here and literally just pour acid into the ones that we have. I'll probably start with about a ½ inch of acid. And I'm going to gradiate it depending on which ones are the worst ones. So the one at 1350, that one's going to get pretty much a fair amount of water, pretty much all the way up to the top. And the lowest acid, which is 1215, so that means it's low on acid. We're going to fill that pretty much up to the top of the bottom of the cap. And all the other ones, I'll modulate it a little bit less, a little bit more, and then we'll come back and we'll check it in a couple days. All right, we went ahead and added the water and the acid to try to balance stuff out, at least in the first round. We got all the caps back on. I'm going to wipe off the excess water and acid on the tops. We'll put it on the equalized charge for about 30-40 minutes, and then we'll unplug it and we'll use it, try to drain down the battery, repeat that process a couple more times, and then we'll recheck our measurements and kind of adjust from there. It's been about 2.5 weeks since we took the battery off the charger, and we've been putting the forklift to work, probably using it between 15 and 30 minutes of a day. So I'm really satisfied with the amount of life that we've been able to get out of the battery. Now that the battery is discharged down to about 1/8 remaining, we're gonna get it back on the charger and see how much amp hours the charger puts back into the battery. And after that proper discharge and recharge cycle, we will also check the battery acidity levels and make more adjustments from there. So let me go ahead and get this battery unplugged. We'll get it on the charger and we'll see how it goes. The battery has been fully charged, and last night before I left, I put it on an 8-hour equalization cycle. When I came in this morning, I also equalized the battery. It's been about 30-40 minutes. You want to do that before we take our specific gravity readings. That way, anything that's stagnant mixes up and we get an accurate reading. Before, we had a range of 1215 to 1350, which was 135 points. The current readings that I just took put us between 1250 and 1300. That is a significant improvement. That is only a range of 50. Considering the battery's age and where we've come from, this is a huge leap forward, but I am gonna keep tweaking the acid levels sort of over time for the next couple of charges just to sort of dial it in. I know it's not going to be perfect, but we're just trying to create the most healthiest state possible for this very old battery. So overall, I'm real happy with where we at, and that's pretty much gonna be it in terms of what we're gonna be doing with the battery from here on out. We got a little bit of bonus content for you guys. It's been about 2 months since I bought the forklift and about a month since I did the battery reconditioning, and we've gone through about 5 or 6 charge cycles in that time. And through those cycles, I've been slowly adjusting the battery levels up and down. And I want to go over to the forklift one last time for the video's sake and sort of tell you where we landed with the specific gravity on each of the cells. So I'm going to go over there and get them measured up, and we'll see how we landed. Well, here's the final results, and overall, I think I'm really happy. When we started out on page 1, we had some drastic range from high to low of 135, and the recent measurements we took were within 30 points if we consider number 1 cell, which was at 1255. But if we take that out, we're within 15 points, and everywhere looks really good. Now, if you're a professional battery reconditioner, you're going to be using 100% acid and cutting it yourself, so you're going to be able to make changes to the specific gravity a little bit quicker. But what's commercially available to the general public is 37% acid, which is pre-cut. It's less aggressive, so the method we've been taking has been slowly adjusting the levels over time as we charge it. So our changes have been slow, but they've been safe. And after about a month and a quarter, this is where we landed, and I'm really happy with it. So with that being said, we're going to be done making adjustments for now, and this is something that I will check every 6 months. But overall, I think we're really good compared to where we started. That's a wrap for today's video, and I know it's been very detail-oriented and long-winded, sometimes even boring, but I tried to be as detail-oriented as possible because there are a few of you guys out there that are going to try to attempt this yourself, and I wanted to give as much information for those folks as possible. That way you can have as much success as we did. Now, our forklift battery is 20 years old roughly, and it's not perfect. It will need to be replaced, but considering that, I believe it is in the best health or the best chance of survival that it can be, and hopefully this repair will get us down the road for 6 months, a year, maybe even 2 years until we have to do the inevitable and replace the battery. So if you guys enjoyed this video, let me know down below, and until next time, we'll see you in the next one.